Everyone, today we are going to discuss new unit, that is permanent magnet brushless motor drives. So in the permanent magnet brushless motor drives, we'll try to see why we need to go with the permanent magnets, and why there is a need of brushless motors, what are its classifications, and its construction, its principles, and we'll try to see the modeling. Okay, first let me try to uh, go why we need to have permanent magnets. Okay, why we need to go with the permanent magnets? So in general, in AC machines or in DC machines, we use electromagnets. we use we use electromagnets. So here we can able to, the advantages are with this is we can able to control flux. We can increase the flux or we can decrease the flux. We can turn on, we can turn off as much as required. We can able to control with the electromagnets. Yes. So now here, instead of electromagnets, I'm using the permanent magnets here. Okay, and as I'm using the permanent magnets here, it is called as permanent magnets brushless permanent magnets motors. Now coming to the next thing is why I'm going with the brushless motors here. So why I am going with the brushless here? So you might have already known this. In DC machines we use commutator and brushes here. The purpose of the commutator is to convert AC to DC and DC to AC in case of generator as well as motor here. Okay, so it is called as mechanical rotating rectifier here, and purpose of the brushes is to collect the current. Purpose of the brushes is to collect the current here. Now here, in the whenever we use commutator in the DC machines or any slip ring induction motor here, where it is here whenever I use any commutator in the DC machines, so here there are more chance of sparks. That may occur in the machines here, and brushes when it is collecting the current here, and so there are high chances of sparkings. So these are the problem that we normally occur. And for a rotating machine, I cannot able to transmit more amount of power here, and because of this constraint, so instead of brushes, if I go with the brushless motors, then that will be a huge advantages, and that we are going to implement in this permanent magnets motors here, so that together we can combine this permanent magnet brushless motors here. So here the advantages, I will try to add one more advantage with the permanent magnets here. So I will try to we'll try to discuss one by one what's actually it is and what are the advantages. Okay, and what are the classifications here. Okay, so coming to this permanent magnets here, so okay, we'll try to discuss advantages of permanent magnet brushless motors. So the major advantage is high power density. What is high power density here? So the use of high permanent magnets allows the significant reduction in the size and weight of the machine here. This is the major here in EVs, particularly the size is major constraint here. The size of the machine is major constraint. We all know size and weight should be less. So here in this regard, what we can say that by using the permanent magnets, the size and weight of the machine will be reduces, and this will be the major, and we can able to generate more amount of power here. What is power density? Power density is nothing but per unit volume. the power density is more here, and high efficiency, we can able to obtain more high efficiency, because in electromagnets rotor copper losses, the winding will be there, and in the winding rotor copper losses will be generated here. Rotor copper losses generated here. With the permanent magnets, no such rotor copper losses will not be there here, so that obviously when losses are reduced, efficiency will be increases here. And improved thermal management here, the heat generated in the primary concentrator winding is making it easier to dissipate and control the temperature here. Enhanced reliability, the use of permanent magnets eliminates the risk of manufacturing the defects, overheating. So, and coming to the disadvantages here, the cost is high, because these are the rare earth elements present in the earth, and significantly increases the cost here. And mechanical integrity concerns here, mechanical integrity of the rotor, especially surface mounted permanent magnet motors. We'll try to discuss this types once we actually get into the topic here. So can be challenged at high speeds here. Limited constant power range here. So the uncontrollable nature of the permanent magnets. So the major concern is permanent magnets fluxes cannot be controlled here, so that the speed ranges can be operated for constant power range here. And risk of demagnetization here. Improper design and operational lead to demagnetization of permanent magnets here due to the armature reaction of fields.